Okay, now we're going to come to the second one here. And this is where I really want to focus on acknowledging that in the lecture, you might have used the words fat and skinny. The goal of this particular lab and the goal of mathematics at higher levels is to say, this is what I observe. What is the causality behind what I observe? So here's what we observe. When A is increasing, the function does appear to get skinnier. But the question is, why is that the case? And obviously, when we are negative, it also, I hate to say flips, but it basically reflects it across the y-axis. So again, we want to ask that question too. So let's start off with thinking about, from a pointwise perspective, what's going on. Okay, so we take a look here. I'm going to make A positive first. And what you want to think about is, if I make A, let's make A 2 because I think it's a little easier to look at. What do we notice here? When we had changed the first, when we changed the parameter that was just the additive component, we were shifting. But now you can see it's not that clean shift. It's more, it moves a little bit more jerkier. And the reason for that is because what we're doing now is you can see that the difference between here, well, between here is going to be a lot less than the difference between there and there. So the question is, if the difference is growing, right? The difference here, this is 8 and this is 4, so that's a difference of 4. Whereas if we look at this one, let's say here, this is 18 and 9. Now we've got a difference of 9. So that explains why it appears to be getting skinnier, because as x increases, the distance between the two graphs does increase. The question is why. So what's happening from a pointwise perspective is that the y value has a multiplicative effect rather than an additive effect. So as the y values increase, then when you multiply them by a number, any positive number, they're going to increase. When you multiply them by a negative number, right, the y value is going to become negative. Plus, in this case it's by negative 0.5, you're going to cut this amount in half. The distance between 0, the x-axis, and the point, you're going to cut it in half, and then you're going to multiply it by a negative. That's why it reflects across the y-axis, because it's the y that's changing sign. So what's interesting is before we looked at a constant difference between the original red function and the transformed blue function. Here, what we see is the ratio is what stays constant. So in this case, I can look at, let's say, g of p. Again, p is the purple point there, divided by f of p. And what do you see? It's negative 0.5, which is the exact value of a. As I change a, you can see that if a is 1.5, the ratio is 1.5. So once again, you have this idea of the reason that it's appearing to get skinnier is because the distance between these guys is growing, and it's growing at this rate, a multiplicative rate. All right, and the same thing is going to happen if we change this, for example, to x cubed. Oops, not x to the third. There we go, x cubed. Okay, it's going to go quicker. You can change the scale here, just hit the shift key and bring that down. But you can just look at the ratio between any of these 2 points at g of p. Maybe I should label that p so that you can see. But right, from 12 to 8, the ratio is 1.5. As I go up here, the ratio between the y and the x is still 1.5, but the actual distance between them is much bigger. It's almost 10 units here, whereas when you go back to here, it's, only 4 units. So that's hopefully going to help them with understanding the difference between causality and observation. So that's what we hope they will say here. And then one of the other changes I made here is that when they do this sine of 2x, again, obviously you want the amplitude to be in blue, and remember that they plotted points like we did. That was a really good idea. And also I had to change the scaling here. So for some reason it didn't keep the numbers, but anyway, I had to change that scaling. So that's another reason to download the function. Okay, I'm going to stop this video now so that you can think about what I just said and think about what you might expect them to explain for changing of a.